Okay, this is the P1 paper for January 2023. It's question number 7, and this is a graphs and transformations question, and then a little bit later on there'll be some work on quadratics. Let's jump straight in and have a look at it. It says, on the diagram, sketch a graph of y equals 6 over x. So 6 over x, the reciprocal graph, is one of the many graphs that we should just know the basic shape of. You should know quadratics, cubics, your trig functions, but in particular 6 over x then is just the reciprocal graph. You can draw what looks the same as y equals 1 over x and 6 over x, because 6 over x would just be a multiplier which would just stretch it, but as we've got no points of reference here, 6 over x and 1 over x for the basic shape look exactly the same as each other. So part A done. Part B, what does part B say? So part B says we've now got to transform it to 6 over x minus 2 and describe that transformation. So again, really basic knowledge here that we should know that if we've got f of x minus 2, what does that do as a transformation? And that just translates it 2 units to the right, but I'm actually going to say that better. The actual answer, I would say, in fact, let's get rid of that just so that I don't confuse the examiner. This is just a translation, and I'm going to use the column vector to show that the whole graph would move 2 units to the right. So part A and part B, very straightforward. Part C says we've got the curve here and we've got a straight line here, and they intersect at 2 points, P and Q. They tell me that the x-coordinate of point P is minus 4 and ask me to find the value of K. Let's just explain what's going on then. I'll actually use the graph I've got here. I know this is 6 over x rather than 6 over x minus 2, but 6 over x minus 2 would just be shifted over a little bit that way. And if we're going to have y equals kx plus 7, that's just a straight line which is going to hit this curve at those 2 points here. So what they're saying is that one of the values, x is equal to minus 4. That's going to be my P. My Q would be over here as the other solution to the equation. I'm just going to get rid of all that just to put it back in terms of my answer for the previous part. That was just to explain it to you guys what was actually going on. So let's leave that like that now. But in terms of actually solving this then, for part C, all we need to do is to solve the equation where is 6 over x minus 2 equal to kx plus 7. But as we said, they've told us that this works when x equals minus 4. So at x equals minus 4, I'm going to get 6 divided by minus 6 is equal to k lots of x, so minus 4 lots of k plus 7, so we can work out what k is from that. We get minus 1 equals minus 4k plus 7, so we're going to get k working out to be equal to 2 there. Not difficult at all for the algebra for that part there. And then for part D says find the coordinates of the point Q, which in other words is solving this equation now and working out what the other one's going to be. So we had 6 over x minus 2 is equal to kx plus 7, but I know that k is equal to 2 now, so it's equal to 2x plus 7. That's going to turn into a quadratic, 2x plus 7, x minus 2 here. Multiply everything out, we're going to get 6 equals 2x squared plus 3x minus 14. Turn that into a quadratic equaling 0, 2x squared plus 3x minus 20 equals 0. Now, as I say, I think that a lot of you should actually be able to factorize this straight away by looking at, we know that these two terms, for example, are 2x and x, and then just have a play around with the numbers to try and get that situation there, which is going to give me x working out to be equal to 5 over 2, or x working out to be equal to minus 4. So the actual point that we would be looking for, Q, would be 5 over 2, excuse me, would be 5 over 2. And then what's the Y value going to be? Well, you can just put 5 over 2 back into kx plus 7, or rather back into 2x plus 7 there. And that gives us the answer, excuse me, of 12 there. Let me just quickly, so that's the answer. You can stop the video there for most of you. If you want me to just show you how to factorise 2x squared plus 3x minus 20, if you couldn't do it straight off, and obviously you could use a quadratic formula to do it, but another way to do it is to use the AC method. If I'm factorising, AC method means A and C there. So A times C makes minus 40. So what we're looking for is two numbers that multiply together to make minus 40, and those two numbers must add together to make 3 there. So the numbers that work out to be 40 are going to be 8 and 5, aren't they? If I went and end up with plus 3, then I think I'm going to have 8 and minus 5 as my numbers. So what they do is they now just take the place of the 3x. So I would have 2x squared. Instead of plus 3x, I'm going to have plus 8x minus 5x minus 20. Look at this left-hand side here. Factorise that, which would be 2x coming out to leave me x plus 4. I must have x plus 4 in here. So what am I taking as a factor out of minus 5x minus 20? I'm taking minus 5 out there, aren't I? So I end up with 2x minus 5x plus 4. By all means, do that. You can see how long that's taken to do that red part there. I would encourage lots of the stronger people to be able to try and do it straight out. But if you can't, absolutely, there's no problem with doing that. I'm going to get rid of that as part of my answer, though, and we'll leave it with what we've got here for a relatively straightforward question number 7. Okay.